Hello, my name's Mark Higgins and I'm going to be presenting to you the year of 2013 as seen from the world's weather satellites. What you can see here are the global ring of geostationary satellites and the infrared images from them. So you're looking at the coldness of clouds, that's what the white shows you. So the higher and colder a cloud is, the more white it is. We've put the images over NASA's blue marble and it'll change with the seasons. So you can always see what sort of season we're looking at. So three things to notice the sort of broad structure of the atmosphere during the year. You'll see in the north and the south these flow of storm systems moving from the west to the east. And they're a little bit symmetric, and we'll explain more about that later on. In the center, in the equatorial regions of the Earth, you'll see this pulsating flow of smaller clouds, but with much brighter white tops. And that's what we call the intertropical convergence zone. That's where air from the north meets air flowing up from the south, forces that air to rise and generates these tropical storms. Effectively, what you're seeing is the tropical rainy season. What you might want to do is watch these systems and see how they move north and south through the year as the relative position of the sun changes. So here we're coming into Northern Hemisphere spring and Southern Hemisphere autumn, and you'll see those storms in the Southern Hemisphere that scream around the southern oceans. Very little land to take away their energy. When a storm hits land, the friction between the storm and the land surface takes away some of the storm's energy. Very little of that in the southern oceans. So these storms move around very, very fast. You'll see in the Northern Hemisphere, as those storms come across, say, the Atlantic or the Pacific, they hit the land and their intensity reduces a bit. The northern and southern hemisphere systems are driven by the jet stream. So effectively what you've got is the very, very cold air towards the poles and the much warmer air towards the equator causes a rapid change in temperature. And this boundary at the top of it, you have the jet stream, which drives where those storms move. And effectively what you've got there is the atmosphere trying to equalize the temperature. And because the Earth is rotating, this battle between the cold air and the warm air results in rotational storm systems that are then driven by this jet stream, which is a very, very fast wind, very high up in the atmosphere. As we move towards the middle of the year, you'll see now that the southern hemisphere storms have moved further north. They're now starting to just come across Africa, Australia and Latin America. And you'll see the northern hemisphere system starting to weaken a bit as we come into the middle of the northern hemisphere summer. In the tropics, you'll see this band of cloud. It seems to pulsate. What that is the variation during the course of the day. So as the sun heats up the land surface, that rising air then rises even faster. That more dramatic rise leads to greater storm systems, and so in late afternoon, early evening, you see these storm systems developing, and you can see that in these much brighter pieces of cloud. So this is why you see this sort of pulsating as you look at that tropical region. And you'll see in the NASA blue marble, the green changes throughout the year, and there's a delay between where the tropical convergence zone is and where that green is. So it takes a couple of weeks for the vegetation to start to grow as a function of the rain it's receiving from from that storm system. So have a look in the Western Pacific right now, and we'll start to see the typhoon season there grow in strength. And you'll see these small cloud systems which then develop, and some of them will just develop a little bit and then disappear, but some of them will develop, gather a lot more rotation, and the storm system will develop into a tropical cyclone. In this particular region of the world, of course, they're called typhoons. And you'll see the typhoons tend to have quite curved tracks. When they get really developed, they'll have that very classic center of the hurricane or center of the cyclone eye that you'll see. And what drives the cyclone is the amount of energy in the sea surface. So if the cyclone travels over a warm patch of ocean, it will then be able to grow in intensity and therefore impact if it hits the land. And this is one of the great challenges of tropical cyclone forecasting, is to know exactly where will these things strike land. They're incredibly dangerous, and of course in 2013 we saw tropical cyclone Haiyan, which went across the center of the Philippines and then actually also caused great damage in Vietnam and towards southern parts of China. In Europe, this is now our storm season, and early on, towards the end of October, we saw Storm St Jude, as it was called in the UK, and Christian as it was called in Denmark. A very, very high intensity storm. Very good example of what's called rapid cyclogenesis. So where the rotation of the Earth and the position of the water vapor in the Earth's atmosphere causes storms to rotate incredibly dramatically. And this can, in certain circumstances, lead to incredibly strong surface winds. Which is what we saw in those storms. What you might find interesting to do is to watch this video again without the sound, and just to watch a particular point on the Earth, choose one that's of interest to you, and see how the Earth's atmospheric system changes in that place during the course of the year. Or watch how these systems move north and south, or the cyclone seasons change in intensity during the course of the year.